Hello everyone, welcome to the demonstration of data structures laboratories experiments. Today we people are going to demonstrate experiment 9. Aim of the experiment is to design, develop and implement a program in C for the following operations on singly linked list with header nodes. Represent and evaluate a polynomial p of x comma y comma z is equal to x square y square z minus 4yz to the power of 5 plus 3x cube yz plus 2xy to the power of 5z minus 2xyz cube. Find the sum of two polynomials poly 1 of x comma y comma z and poly 2 of x comma y comma z and store the result in polysum of x comma y comma z. Support the program with appropriate functions for each of the above operations. So the aim of the experiment is to design a program using circular singly linked list to implement a polynomial, and the operations that are to be performed on the polynomial is we have to evaluate a polynomial, and the second operation we need to do is we have to add two polynomials poly 1 and poly 2, and the result of the polynomial we have to store it into the third polynomial, that is polysum. So before beginning with the experiment, first let us understand what a polynomial is. A polynomial is a sum of terms where each term has a form a into x to the power of e, where x is the variable, a is the coefficient, and e is the exponent. So what is a polynomial? Polynomial is a sum of terms where each term has a form a into x to the power of e, where x is the variable, a is the coefficient, and e is the exponent. So the polynomials can be represented as, say we have written two examples here. A of x is equals to 3x to the power of 20 plus 2x to the power of 5 plus 4, and b of x is equals to x to the power of 4 plus 10x cube plus 3x square plus 1. So here you can find out that every polynomial is a sum of terms where each term is of the form a into x to the power of e. If you consider a term 3x to the power of 20, 3 becomes your coefficient, e is 20, that is the exponent, and x is the variable. Now, the aim of the experiment is to design a program to represent a polynomial using circular singly linked list. So first thing is that in order to represent a node using a circular singly linked list, we require a node. So in order to represent a node, we will use a structure. And in this, the node for a polynomial should consist of 5 fields. One for the coefficient, second for the x term, x variable, next for the y variable, and the next one for the z variable, and the fifth field for the link. So this is how the term should look like, as what I have shown in the box in the right side of the page. So here the node for the polynomial should consist of 5 fields. So similarly, we are taking CF, PX, PY and PZ of type integer, and link is of type struct node, and it is a pointer, and this link field will be pointing to the address of the next term in the polynomial. And in order to refer all these members in this node, we require a variable, and that variable name is node. Then using the above structured definition, the polynomial this polynomial can be represented as shown below. So we have considered a polynomial 5x cube y square z square plus 3y square plus 4s cube z. So this polynomial using the above structure, it can be written as p is a polynomial, that is it is a pointer which is pointing to the first term in the polynomial. So the first term here is 5x cube y square z square. So 5 is the coefficient, 3 is power of x, 2 is power of y, and 2 is power of z. So this happens to be the first term. Then the second term is 3y square. So the link field will be pointing to the next node here. So 3 is the coefficient, x term is not there, so the power is 0. Y term power is 2, z term is not existing, the power is 0. Then there exists a third term, that is 4x cube z, wherein the coefficient is 4, power of x is 3, power of y is 0 and power of z is 1. Okay, so the third term is pointed by the link field of the second term. Now assume that we want to add the next term, that is the fourth term in the polynomial, that is 6z. So that term can be added at the rear end of the polynomial. So we will create one more node, and here in this node we will add the term 6 is the coefficient, x, y variables do not exist, so they are 0, and the z variable, its coefficient is 1. So this polynomial, now you want to represent it using a circular singly linked list. So what we can do is we can take a head node. As we are using a header node to represent a polynomial, and the head node will be holding the address of the first node. So this head node also should have 5 fields. And the address of the first node will be pointed by head, and the link field of the last node will be pointing to the header node. In this way, a circular linked list can be represented. Now we will try to implement the program. So before the program begins with, we people will include the header files. So this first header file, it is used to define the input output functions that are used, and the second header file is used to define, or it is used to represent the mathematical functions that will be used in the program. Then this is the node structure which we have already discussed. Then the next function is the insert rear function, which will play a very important role in adding the node into a polynomial at the rear end. So now suppose this polynomial we have, and we want to insert a node at the rear end. Then first, for a temporary node, a memory will be allocated. Now assume that this is our temporary node, and we want to, this will be the new element that will be added into the polynomial. So this polynomial is already existing. When we add a new term, suppose the term is 4x y square z cube. So this term we want to add it into the polynomial. Then this is the temporary node that is created. In the coefficient field 4 we have stored, in the x term we have stored the value 1, that is power of x, then we have stored the power of y, then we have stored the power of z. Then we will take one pointer, that is the current pointer, and the current pointer should be pointing to the first node. So how can the current pointer point to the first node? So for that we will take current is equals to head arrow link. So current will be pointing to the first node here. Then we have to reach the last node. So for that this while loop will be used until unless the current's link is not equal to head, update the current. So current's link is not equal to head. So update this current. Now current will come to the next node. Then again the current's link is not equal to head. Bring the current to the third position. Then bring the current to the fourth position. Now the current's link is pointing to head. Here in this situation, this while statement will fail. Now at this position, what we can do is, now we can insert the temporary node, that is the new term in the polynomial, between the current and between the head. So what we will do, we will establish a link between, current and temp. So we'll establish a link between current and temp, and then we will establish a link between temp and the current, and we'll establish the link between the temp and the head. So in this way, a new node will be inserted into the polynomial at the rear end by executing the statement current arrow link is equal to temp and temp arrow link is equal to head. The next function that we people need to learn is the read poly function. With the help of this function, it allows the user to read a polynomial. So here, when this function is called, the user is asked to enter the number of terms. Once the user has specified the number of terms, then in this for loop, based upon the number of terms the user has requested for, those many number of times this for loop will repeat. Then the user is requested to enter CF, PX, PY and PZ, And with the help of this scanf, the user with the help of a keyboard can enter the coefficient px, py and pz values. So this process will be repeated until unless n number of terms are been read. Once each time a term is been read, a insert rare function is been called, and in this way the polynomial is been constructed. Then the next function is the display function, wherein what happens is we have a polynomial in this form and we want to display the elements in the polynomial. So before displaying the polynomial, the first thing we have to check is whether the polynomial is empty or what. So before displaying the elements in the polynomial, the first thing we should do is we should check whether the polynomial is empty. So the condition is head arrow link is equal to head. So we know that head is pointing to the first node in the polynomial. If the head's link is pointing to itself, that indicates that the polynomial is empty. In this condition, it is not true. We have some nodes in the polynomial and we want to display it. So for that, we will use one temporary node, and that node will be pointing to the first node by using the statement temp is equals to head arrow link. So now temp is pointing to the first node in the linked list. Then when we obtain the address of the first node, so first check whether temp is not equal to head. This condition is true. Then take the coefficient of temporary node. So the coefficient of temporary node is 5. Check whether it is less than 0. It is not less than 0 because it is a positive number. It is 5. It is greater than 0. So come down to the else part, append plus a sign and print temp arrow cf. So plus 5 will be printed. So what will happen? Plus 5 will be printed. Then come down to next if statement, if temp arrow x is not equal to 0. So temp arrow x is 3, so it is not equal to 0. Then you have to print x, then caret symbol, x to the power of whatever the px value will be. So it is 3. Then come down to the y value, that is temp arrow py is not equal to 0. It is 2. It is not equal to 0. Then we need to print y to the power of 2. Then next come down to temp arrow pz not equals to 0. Then print z to the power of z to the power of 2. In this way the first term will be printed. Then temp will be incremented to the next by using temp is equals to temp arrow link. So now the temp will move to the next node. Then in the way how we have displayed this first element, in the same way the second term will be displayed after displaying the second term. So the second term is what now? It is 3y to the power of 2 because we don't have the x term there. Then next temp will be incremented, temp will be moving to the third node. Then this element will be printed, that is 4x to the power of 3 and z. So it will print here 4x to the power of 3 and z. Then next lastly the temp will be moving to the last node here, and now it will print 6z to the power of 1. In this way the polynomial will be displayed. So this is how, with the help of the display function, it is possible for us to display the polynomial. Then the next function is to add the elements in the polynomial. So for that, this function I have already explained in the class. So with the help of an example, I'll try to explain how polynomial addition is being done. So here we are having two polynomials. One is 5x square. Now for the simplicity's sake, I have taken 5x square 4x plus 2 so that you people can understand it. So a larger example is already taught in the class. You can refer the notes and the videos which are already been uploaded. So here the first term is 5x square, second term is 4x, and third term is 2. So we are having a polynomial 5x square plus 4x plus 2. Then the second term we are having 5x plus 5. Then now we need to add these two polynomials and then we have to obtain the third polynomial. So the first search operation begins from this, and we have to search for 5x square. Check whether a term with x square exists in the second polynomial. So here you see x power is 1, here x power is 0. We don't have a term with x square, so that term is not existing. So simply take this 5x square and keep it into the resultant polynomial. So insert from rear in the resultant polynomial, that is 5x square. Then move to the next term, it is 4x. In the second polynomial, check whether there is a term with x to the power of 1. So here there is a term with x to the power of 1. So both are having the same power, having the same degree. So add these two. So this will be 4 plus 5, 9, 9 to the power of 1. Then go to the second term. Second term is 4x to the power of 0. So this becomes, sorry, 2x. Then check whether there is any term with x to the power of 0. So in here in the second polynomial we have x to the power of 0. So matching term exists. So add this 2 and 5 coefficients. So we'll get 7. So 7 into x to the power of 0. Create one term and add it in the resultant polynomial. In this way, the polynomial is to be created. Is in this way, the two polynomials are to be added and the resultant polynomial is to be created. Now this is the screenshot of the output what we have obtained. So when we execute the program will ask you one for evaluation and two for sum of two polynomials. So how exactly it is been done? So here while going to the main function, we have used a menu driven program. So here we are using three pointers h1, h2, h3 and another pointer that is head. Head is pointing to the header node and h1 is a pointer to the first polynomial, h2 is a pointer to the second polynomial, h3 is a pointer to the third polynomial. Then we will allocate memory for the head by using the malloc function. Then head arrow link is equal to head. We will make it as null, means empty. Then we will allocate memory for h1. Then h link is pointing to h1. Then for h2 we will allocate the memory and similarly we will allocate the memory for h3. Then in the do while loop, we will write a printf statement wherein we are informing the user to press 1 for evaluation and 2 for sum of two polynomials. So based upon the choice of the user, either case 1 will be executed or case 2. So if the user hits case 1, then a read poly function will be called and a polynomial will be read. Then by calling the display function, the polynomial will be displayed. Then the evaluation function will be called and the polynomial will be evaluated. Then the second case, if the user hits 2, that is sum of two polynomials, and the second case will be executed. Then using h1, first polynomial will be read. Then using h2, second polynomial will be read. So for reading the two polynomials, read poly function will be called. Then after reading both the polynomials will be displayed. So you can see here display of h1 function is called. Then in order to display the second polynomial, display of h2 is called. Then now we want to add the two polynomials. Then add poly function is called by passing h1, h2 and h3. Once the polynomials are been added, then the result will be displayed. So coming down to the snapshot of the output here. So here the user has pressed 1. Then the program asks the user to enter the number of terms. So user has pressed 3. So the user is asked to enter first term, second term and third term. After entering all the three terms, the polynomial is been displayed. Then in order to evaluate, we have to give the values of x, y and z. The user gives values of x, y, z and after evaluation, this is what the output we get. Then the second option is the sum of two polynomials. So when the user hits 2, then it will ask you to read the first polynomial. Then after reading the first polynomial, the user is asked to read the second polynomial. Once reading the first and second polynomial, the first polynomial and the second polynomial is been displayed. Then the resultant polynomial is been displayed after addition. So this is how the program can be executed, implemented and executed. Now we will go to Turbo C. I have already typed the program. Now we will try to execute the program. So we'll open the program. We will compile the program. The program has no errors. Then we'll run the program. Once we run the program, here the output screen appears. Then I can press 1 for evaluation. Then it is asking me for the number of terms. So I want to give 3 terms. So it will ask me for the first term. So I'll give 5x square, y cube, z square. So 5 is the coefficient, 2 is x to the power of 2, 3 means y to the power of 3, 2 means z to the power of 2. Then I'll give 4y square. Then, so now it has become a mistake here. I have given 4 and 2. So it becomes 4x square y and z square. So this is the term I have given. Then the third term I want to give it as 6z. So I'll give 6. X I don't want, y I don't want, z I want it as 6z. So the polynomial I have entered is, say I have given first term as 5232. So I have given 5x square y cube z square. Second term I had given it as 4212. So it is 4x square y to the power of 1 and z to the power of 2. And the third term I have given it as 6001. So that polynomial, that term is 6z. Now I have to give the values of x, y, z. So I'll give x as 1, y as 2 and z as 3. I'll enter the I'll press enter. So you can see that output is displayed. So after evaluation, output is 450. You can manually enter the value for x, y, z in the above polynomial and you can cross verify. You will get the output as 450. Now the next option is I have to give 2 as an option. So when I press enter, then it is asking me to give the first polynomial number of terms. So if I give the number of terms as 1 for the first polynomial, then I will give it as 3x square y cube z square. Then second polynomial, because I am interested in giving only one term in the first polynomial, so I have given as 1 here. So in the second polynomial also I will give only one term. Then it is, this is what the polynomial is. After reading both the terms, it will display the first polynomial, then it is displaying the second polynomial, then the resultant polynomial is been displayed. So this is how the program to implement operations on polynomial using circular singly linked list can be implemented. So in this program, we are performing two operations. One is evaluation of the polynomial, and the second operation that we have implemented is addition of two polynomials and displaying the resultant polynomial. So this is how the program can be implemented and executed. Thank you.